I'm going to ask each of you the same question for the first round, and it essentially is, what's the biggest challenge to your technology moving forward? Andy?
So the biggest technology challenge here moving forward is getting through what we know works in the field. See, Admix Innovations is a technology company. The technology is solving for the dispersion and the cohesion inside of the mix. So as we start walking through all of the different details, what we know works in the field still has to be proven in the lab, and then ultimately has to go through the code base, the building code alignments, and get approvals for use everywhere. So the biggest challenge we see is changing the mentality of the marketplace, right? You know, why it wasn't invented here, how come it's not worked before, what if we need another test, how are we going to disrupt and change the sequence? So the challenge is really awareness, and really being able to let everybody know that what the industry has been chasing from a utilization of nanomaterials, specifically graphene, is now within our reach.
Philip?
There are multiple things, but I would say a key one is upskilling the labor force. So this type of new machinery, it still requires human operators, and it's a completely new way of thinking about construction when you 3D print a home versus laying bricks or laying something else, right? So upskilling the labor force is super important, which is why we do all we can to disseminate knowledge in the field. That's why we have research partnerships and academic partnerships with, say, the University of Miami, for which students here have already taken classes by Cobot on 3D construction printing. And I think that's only going to be more and more important in the future. Right now, young kids, they don't really want to go, for the most part, into construction. They don't think it's that you can say sexy, right? Whereas we see with this technology, we often have hundreds of people lining up just to see the process. And we hear from all of these operators on our side, and our client side, that they really want to get in there. It's almost like playing a video game. But that has to be coupled, the passion has to be coupled with the teaching of the technology, and that's what I see as the most important factor moving forward.
Ken?
I'm going to jump on what Andy said, awareness. So we're out to try to change people's paradigm of designing and building with wood, steel, or concrete into something that they don't quite understand, they don't know. So for 100 years, that's all we've been able to do. We changed the code. It took us 10 years to get it done, but we changed the code. So our biggest obstacle now is to educate people like you. So when you're designing, you have other options. You have solutions to come up and look at different situations. And instead of using wood, steel, or concrete, you can use a composite. Builders, the same thing. There is a low barrier for entry here for us. You need labor who are willing to work, who can swing a mallet, and who can lift block that weighs 4 pounds. So if we can do all that, we can potentially change a lot of things in the construction industry. And it's an enormous market. We talked about it earlier. There's 1,500,000 housing starts in the country on an annualized basis. Most of those are in Florida, Texas, and Arizona. So if we focus on those areas where people are moving and provide an attainable housing option for people, we're going to solve a lot of problems.
Yeah, I think to reiterate that, right, technology is changing faster than the building code, and that's been a struggle, whether it's been 3D printing, whether it's introducing new materials. And so I think until we can kind of figure out the pacing of technology and how we can implement that quicker into building code to solve these questions of affordable and kind of actually just providing enough housing for people, that's going to continue to be a huge problem. I think another one is looking at these systems as a researcher and trying to get the ability to play with all of these different systems, is realizing that some of them are very good at some things and not great at other things. And typically you're having someone come in with a kind of whole building solution saying, I've solved everything, when really, if we can kind of work together and say, our product solves this problem, our product solves this problem, and bring those people into the same room, I think you'll see a lot more innovation happen there than a kind of single provider solution.
Ken, what are the structural limitations to your product? We saw a 5-story building that was impressive. Is there a point where you have bending and problems?
No, not from a structural standpoint. So we worked with the IBC and came up with a solution that's an evaluation criteria. It was publicly vetted in St. Louis about a decade ago, and then we tested for 10 years to prove our concept. Structurally, we're pretty darn good. Fire ratings, we have 1 and 2 hour fire ratings, but what the code said is before you run, you need to walk, so you got to show us. So they approved construction type 5A and 5B buildings, which allow 4 stories above grade plane, 5-story building. So that's where we're at right now. We are doing continued testing. The block itself has passed a type 1, 2, and 3, it's an ASTM E136 fire test. So the block is considered a non-combustible. Now we're working on the flooring system and the joist to meet that same standard.
So it's in progress.
Yeah, it's in progress, so it's always in progress.
Philip, we've seen a lot of great stuff come from your firm that is of smaller size. How do you scale it to larger buildings?
Yeah, as was said here, innovation is always taking place, right? We 3D printed the first building in Europe back in 2017. People thought we were crazy. We managed to do it within 2 months. The second time we did it, we managed to do it within 3 days, 28 hours. Then we went on to 2-story buildings, 3-story buildings. Last year, we delivered a printer to our investor, General Electric, up in New York State, and that machine can print up to 6 stories, or around 75 to 80 feet in height, for printing these wind turbine bases. So, where we will be in 5 years, hard for me to gauge, but it seems just extrapolating where we came from, it's only going to go upwards from here.
Andy, as you know, there are limitations on concrete buildings. At a certain height, we change over to steel. But part of that has to do with the fact that the concrete itself has its limitations. With your product, how much more strength can you develop than what is being done today?
Yeah, great question. So the product being upscaled with Admix Innovations Equinox line is increasing compressive strength by over 200%, while simultaneously getting the flexural strength and the permeability reduction. So when you're able to dose all of them into one side, the mechanical properties really change throughout the entire building cycle. So for example, if we were looking at a slab system and the slab was engineered for certain specifications and 12 inches thick, well, if we could upscale the materials, we could increase all of those attributes in one dose. Well, then theoretically, not only could we lower the cementitious content in the mix design, but we could also reduce the thickness of the material, creating tremendous cost savings and upside for those building the structure. So we believe that this is not isolated to just one mix design. See, Admix is the technology, so if it's a cementitious mix, whether that be a slab, whether that be a beam, whether that be an overlay, a composite deck, we have the ability to treat and upscale that material so that we can really create value equation for it.
Did I hear you say in an earlier presentation that you're able to achieve 15,000 pound concrete nowadays with very little change in what the original recipe was, except for the add of your product?
So yes, we've had very high strength products come out. So for example, there was a field test that we were doing with an auger cast pile, which is before the slabs. And when they originally were coming in, their mix design was a 1-to-1 cement to sand ratio, which is not a very sustainable mix and is quite expensive. So as they were moving through a mobile batching system, they needed a mix design that was a more sustainable item. We reduced 40% of the cementitious material and doubled the compressive strength that they were getting out of their original mix. So the answer is absolutely yes. If we design the mix, we can improve the strengths all the way.
Dean, do we have time to take questions from the audience?
Can you read? Ken, you showed that example, I think it was called Lakeview or something.
Yeah, Lakewood Village.
Lakewood Village. Can you share costs?
Yeah, so look, Coastal builds a lot of buildings, and we have an exhaustive cost audit bank. So if you're in the wind zone, typically you're building with a CBS system for a low-rise structure, such as a 3-story building. Typical cost for Coastal might be in the $35 to $40 range, subcontracted out, furnished, installed, delivered. We're under 30.
And then how do you introduce time as a component to that cost factor? So if let's say if all things are equal in real cost, what is the time?
So time-wise, that structure, they're 29,000 square foot structures. They have 9,700 square foot plate. 3 stories, 8 men, 8 weeks to build that. So 64 man weeks to get that done. If that were a construction job out of concrete, you'd have a crew, you'd have cement trucks, you'd have heavy machinery, you'd have pumps, you'd have cranes, a variety of things. And you'd probably have a crew of about 30 on that job to get it done, if you wanted to get it done in that same 8 weeks. So one thing Renco provides is a solution for labor. I mean, there's not a lot of skilled labor around anymore. And it's kind of a dying breed, not just here in Miami, but throughout the entire country. So our objective is to be able to train anybody who's willing to work on how to work with this product.
Firstly, thank you so much for new materials. We in Miami have a lot of environmental constraints, and also in different parts of the world, namely also in Istanbul. Can you speak to each of your products to environmental constraints and what that could look like?
I'll go first. We use recycled products, so things that people throw away, PET bottles that are up on the table here, they get recycled now. They're broken down, turned back into resins. Resin is the matrix that suspends all of the things in our product that make it a structurally sound solution. Calcite is mined from the earth. It's limestone dust, calcium carbonate, readily available and very inexpensive. Just need to transport it. So we're transporting from Georgia. Florida doesn't have calcium carbonate. And then the last thing is fiberglass. So fiberglass, we're working with Owens Corning on different solutions for recycling in nature. Turbine fan blades, they're enormous. They develop cracks in them. They don't know what to do with them when they're done, so they bury them in a landfill. We're working with OC to come up with an idea to pulverize those turbine fan blades and use it as a filler into our material so that we recycle yet again. So from an environmental standpoint, I think I mentioned it earlier, if our buildings are lasting longer, you're not spending a lot of carbon footprint building new buildings to replace the ones that don't last as long.
For 3D printing, I would say 3 main points how that's being addressed. Number 1, by allowing for new concrete mixes, my gentleman here to the right, that can be 3D printed using our technology, right? So means that you're emitting less CO2 per print. Secondly, the design freedom that you get from letting the machine take a digital file and turning it into something physical means that you can print smarter, topology optimization. So you can print something which is as strong, has the same use case, but uses far less materials, simply because you let a machine do the work instead of a human being. And then the third point I have is that also, with regards to this design freedom, it allows you to design completely new structures with the possibility to address current issues. So one example is that one of our clients, they're called OnePrint, they're using their machine with the University of Miami College of Engineering to 3D print sea hives. So these sea hives are placed underwater to protect against rising oceans and stronger currents. So it's really a new way of tackling existing issues with new technology. And that's why we at Cobalt, we've always had the mindset, which is, don't use technology of the future to replicate solutions of the past. You gotta think completely outside of the box, which is one of the reasons why we love working with the universities such as the one we're sitting in, because all these students, they have all these ideas, life hasn't beaten them down yet, right? So they're thinking completely outside of the box. So those are our 3 ways that 3D printing addresses that issue.
Yeah, sustainability is what the industry is chasing. I mean, the Concrete for Climate Initiative, being able to reduce some of the greenhouse warming potential is without a question there. The inventor of our technology, his lifelong passion is to convert waste materials into the most sustainable building material around. With concrete being the number 2 most consumed item, second only to water, it's a logical place to start there. It's really important to understand that the disbursement technology, while it was sought to solve nanomaterials, which the industry's been chasing since the discovery, the byproduct is that it'll disperse simply anything that you add to the mix. So this opens up new mix designs, new materials that didn't exist before. You may notice in a picture and some samples here, this is recycled rubber tire. again, PET 1 water, plastic bottles, and a host of other alternate positive materials, different attributes. So we agree, chasing that sustainability item so that we can make better, longer lasting structures is definitely the quest of this pack.
And I think just to touch on one thing that Philip said, right, is design plays a big role in that now. Instead of trying to take some of these new materials and shove them into the kind of existing forms that we're used to in construction, using computer-aided design kind of computation, we can design formworks that can reduce a lot of the material requirements in buildings.
Thank you. Guys, we're going to remember this moment as the time you saw a glimpse of the future of the building industry. Thank you very much for fascinating